Assalamu alaikum and welcome to Tech Talks episode 7, made possible only with the collaboration of the NUST Cyber Security Club and IEEE SEECS. The next 2 hours are going to be all about the Arduino. My name is Numan and I, along with Amna, will be your moderators for this session. Amna is an executive in the HR team of the NUST Cyber Security Club, and I myself am the director of the admin events team of IEEE SEECS. For those of you who are unaware of the Cyber Security Club, it is a NUST-based club dedicated to spreading awareness about the threats of the online world. These threats include basic attacks such as phishing to more advanced threats like ransomware. The Cyber Security Club's motives include enabling a secure environment, empowering people with the latest technological trends, allowing you to know the weakness of your own design, and setting out a basic path for those who want to pursue the field. Moving on to the introduction of IEEE SEECS. For the two of you who don't already know, the Institute of Electrical and Electronics Engineers and its affinity group, Women in Engineering, have student branches based in SEECS NUST. IEEE is dedicated to advancing technology, innovation, and excellence, whereas WE is primarily focused on promoting women engineers to excel in their professional lives.
Assalamu alaikum everyone. Let me reveal to you the instructors of this session. So we have here Muhammad Adil Zahid, Maryam Manzoor, Muhammad Ahmed Raza and Misbah Salim as instructor of this beautiful session. Next slide please. While learning splendid things from our instructors, we do expect a discipline from the audience. Kindly don't turn on your mics. Write the questions in chat for the question and answer session. We will have a separate question and answer session at the end, so be patient. In case of any issue or question, please raise your hand. We hope that you will have an informative session with us. Thank you. Handing over the control to our respective instructors. Hope you will learn a lot from this session. Thank you.
Assalamu alaikum everyone. I'm Muhammad Ahmed Raza. Am I audible?
Yes, you are audible.
Okay. I hope you all are doing well. सेशन के लिए अपना कीमती वक्त निकालने का बहुत शुक्रिया. हमारी कोशिश होगी कि आपके इस कीमती वक्त को बेहतरीन तरीके से चैनलाइज किया जा सके और बाय द एंड ऑफ दिस वर्कशॉप आप बहुत कुछ सीख कर जाएं. सेशन के दौरान हम बायलिंगुअली कम्युनिकेट करेंगे. उर्दू का भी इस्तेमाल किया जाएगा और इंग्लिश भी बोली जाएगी ताकि ज़्यादा से ज़्यादा लोग बात को समझ सकें. If any one of you have a difficulty in understanding Urdu, just mention in the chat and we will shift to English. सेशन का बाकायदा आगाज करने से पहले I would like to tell you a thing or two about today's panel and the expertise we bring with us. I am Muhammad Ahmed Raza. Along with me we have Maryam Manzoor, Misbah Salim Memon and Muhammad Adil Zahid. हम सब DeepLift के प्लेटफॉर्म से बिलोंग करते हैं. We have been working on Arduino for a long time now. So आपका माइक्रो कंट्रोलर्स या स्पेसिफिकली Arduino से रिलेटेड कोई भी क्वेश्चन हो तो फील फ्री टू आस्क इन द चैट एंड वी विल बी मोर देन हैप्पी टू एंटरटेन योर रिक्वेस्ट. DeepLift एक लर्निंग प्लेटफॉर्म है जहां हम Arduino प्रोजेक्ट्स बनाना सिखाते हैं. DeepLift को हमने 2020 में फाउंड किया. Our vision is to create a platform where we can inspire individuals and promote creative skills. हमारा मकसद पाकिस्तान में क्रिएटिव स्किल्स को प्रमोट करना है एंड टू मी Arduino अपनी क्रिएटिव स्किल्स और इंटेलेक्चुअल एपिटाइट को चैनलाइज करने का बेहतरीन तरीका है. We have two main sources. Yeah.
Can you please shift to English? We have something in chat related to it.
Okay. We have two main sources of influence, our YouTube channel and our website deeplift.tech. You can browse through our website and see different projects. You can find introduction to the problem statement, required components that you will need to patch the circuit, and complete circuit diagram with clear instructions, and the complete code for the project. These things will come very handy for the beginners. Moving on to today's workshop agenda. In today's workshop, we will start by discussing why learning Arduino is important, and specifically why everyone should learn Arduino. After that, we will learn the prospects of learning Arduino, the career choices that you can opt for, and the skills that you can build on top of the skills that you will learn with Arduino. After that, we will proceed to understand Arduino circuit board. We will study in detail the circuit board of Arduino Uno R3, the components present on it, and the purposes they are performing. After that, we will briefly discuss Arduino IDE. We won't go in detail for this part because we are not focusing on this part for today's workshop. Although we will tell you in detail about the software statements and their purpose, we will use Tinkercad for today's workshop. It is a software made by Autodesk, and it allows you to create circuit diagrams, compile code, and simulate your circuits all in one place. And the advantage for choosing this is that since we are shifted to online, you all can participate and work in the classroom that we have generated. In this section, we will share the link to those classrooms and you can join them. And with the instructor access, we will be able to see your works. And if any one of you have a difficulty somewhere, just mention your username in the chat and we will sort it out for you. Moving on, we will create first project with Arduino on Tinkercad. And in this section, you will be given the opportunity to win 3 cool DeepLift t-shirts. So you don't want to miss this section out. After that, we will proceed to question and answer session. After the question and answer session, we will announce the 3 winners for who will win these t-shirts. So our first section, why everyone should learn Arduino. Arduino is fairly easy to understand. If you want to start a hobby of tinkering or just want to explore it, you would have other options like programming an MCU, but it comes with a lot of challenges for beginners. For example, you need to know the architecture of MCU, microcontroller unit, and you also need to have a good command on Arduino on embedded C programming or assembly programming, which gives a huge learning curve to any beginner. So Arduino bridges this gap by giving you an open source software, Arduino IDE, where you can easily program Arduino circuit boards and enjoy the learning process without investing a lot of time. So you will observe that in today's session, by the end of this session, you will be able to create and understand first project that you will make. Also, it is a fast and inexpensive way of prototyping. So these are some creators that create, and there are multiple, there is a very beautiful community of Arduino online. If you have any query, you find yourself stranded somewhere, you can just ask for help, and people are very friendly on these communities and forums. You can just publish your problem there. And you can see that Arduino changes your mindset. So if you watch Iron Man and you used to wish it would be cool if I could make something like Iron Man. But after learning Arduino, the if I were statement changes to I can. You actually start making things that seemed unreal to you. Okay, so skies are the limit with Arduino. On your right side, you can see a low orbiting satellite made with Arduino. and this satellite is able to communicate with ground stations successfully. Moving on to the next section, what are the prospects of learning Arduino? What are the career choices that you can opt for after learning Arduino? So learning Arduino is a great start to make a possible career in embedded systems. It is a great start to make and find a career in robotics engineering, or even become a roboticist who design, compile code, and simulate robots. Or you can simply become a hobby roboticist like the images I showed you earlier. So let's talk about what is the scope of learning Arduino in Pakistan. On the right side, you can see a vacancy letter from Punjab Group of Colleges, the largest education network in Pakistan, which has opened vacancies this year in May for people proficient in Arduino programming. So you can clearly see a change in interest that people are shifting to more skill-based uh, ways of teaching. So, and also there are multiple offices operating on embedded systems and technologies. Now you will explore what is Arduino and study in detail what is on an Arduino Uno R3 circuit board. For this, I will give access to Mohammad Adil Zahid, who will continue this lecture.
Assalamu alaikum. So now let's move to the main topic of our workshop and see what an Arduino actually is and how you can use Arduino to create interesting robots. Moving on. Just 1 second. Yes, sorry. Yes. As we know, for any robotics or an electronics project, we have two parts. One is your hardware right here, which basically interacts with your everyday objects, and the other one is the software, the code that you write in your IDE. This is basically the set of instructions that you provide for your hardware on what it should act and how it can execute your tasks. First of all, we'll focus our main workshop on the hardware, and once we're done with that, we'll move to software. Now, you can see here, these are the three main terms that are associated with Arduino literature. We will see an in-depth about what they mean, and after that, we'll move on to Arduino. So first up, we have this microcontroller right here. As we already talked about, we have two parts, hardware and software. And we write our software code and upload it onto a chip. This is basically that chip where we upload our code. This contains the arithmetic logic unit. It basically does all the computations for you and runs your code. But one thing to note here is that this microcontroller is just a single chip. It is not really able to communicate with other ports and other input and output devices. For that, we'll move on to our development board. Now, as you can see right here, we have our development board. We have our microcontroller embedded right here, and we have some extra ports. As you can see, we have this power jack and the USB connectors. These actually help the microcontroller in maintaining a stable power and uploading of code. Without this development board, a microcontroller cannot fulfill all the tasks on its own. So that's why we embed our microcontroller onto this development board. Now moving on. One such development board that we're going to take an in-depth review is this Arduino Uno. We'll see what each of these chips mean, how you can use these pins to actually connect your input and output devices. And once we're done with the hardware of Arduino Uno, we'll then move on to software portion. Moving on. So here we have the 5 most common Arduino boards that are available. As you will notice, there's not a major difference among them, except for maybe size and the number of ports that are available. As you can expect, all of these will work just fine on your code that you will write in Arduino Uno. And at the end, it all comes down to what your project specifications are. Let's take a look at each one of them. So this is our Arduino Uno right here. We'll discuss its pin layout in the upcoming slides. But for now, we can see we have this USB connection to upload our code, and we have our microcontroller embedded right here on the development board. Now moving on, we have this Arduino Nano. This is much more smaller in size than compared to Arduino Uno, and so has a lesser number of ports available. That means it is smaller in size, and you can connect less number of devices to it. So let's say you have an application. Let's say you're making a remote for your remote control car. So as you may have guessed, the size is of a particular importance here. You wouldn't want your controller to be too big, so you would prefer Arduino Nano over the Arduino Uno here, so that your controller is small in size. Now, moving on, we have this Arduino Mega right here. As you can guess by the name, it's much more larger in size than Arduino Nano and has much more number of pins available. So that means if you have a project where you're expecting a large number of input and output devices, so you can prefer Arduino Mega over Uno and Nano. We have the same USB connection for uploading the code. We'll see the details later on, and we have a microcontroller embedded right here. Next, we have this Arduino Leonardo. It's a much more recent version of Arduino Uno, but among the tech community, Arduino Uno is still preferred over Arduino Leonardo. Nevertheless, it's much more similar to our regular Arduino Uno and has a similar number of pins available so that you can connect your sensors or any other input-output devices. One difference right here is this USB port. As we saw earlier, Arduino Uno had a different type of USB port. This one right here is micro USB, so that's one change in Arduino Leonardo. And now then we have this Arduino Micro here, just like Arduino Nano. It's smaller in size, and pretty much it does the same similar functionality to Arduino Uno and Arduino Mega. So we can see as a summary of all these 5 Arduino boards that there's not really much of a difference among them, except for their size and the number of pins that are available. So you can expect there to be a board for every type of project that you're working on. Now, moving on, we have these 2 major terms. These are oftenly confused together by the beginners, but we'll try to break them down for you and show you which one is more relevant to our case. First of all, we have a microprocessor system. As you can see here, this little box here is our microprocessor, which contains the CPU and the arithmetic logic unit. It got the computing power to execute your code, but on its own, it can't really function and complete your task. So for that, we would have to interface some external devices like RAM, ROM, and communication ports. And once these are connected, then your microprocessor will function properly. And without them, the microprocessor can't really function. However, if you compare this to your microcontroller, we can see that all of these devices and your CPU is embedded onto a single chip. That means that microcontroller is not only smaller in size, but is also easier to use by the programmer, because he doesn't really have to interface all these external RAM and ROM to the CPU. So that actually saves a lot of effort on the programmer's end. And as we already talked about, Arduino is our microcontroller. Now let's take some example and see where we can find some microprocessor systems and microcontroller. If you look around, your laptop or your computer has a microprocessor system on your motherboard. It's probably manufactured by Intel or AMD, and on the same motherboard that it is embedded, you will find your RAM and ROM as well. And interestingly enough, if you disconnect your RAM or ROM from your motherboard, you will notice that your processor will stop functioning. If you compare this scenario with your microcontroller like an Arduino, you will notice that it will work just fine out of the box. That means if you buy an Arduino right now, then you can pretty much start working on your projects right away without having to worry about these devices that you have to interface. Now, one thing that I would clear up at this point, that even Arduino is not just a standalone device. You would still have to connect some sort of input or output devices. Just like you connect your keyboard or mouse to your computer, you would still require some sort of input or output devices with your Arduino. As an example, we can say that, let's say you were making a light automation system for your room. You would want your light to turn on during the day, or maybe turn off during the day and turn on at the night. Then you would require a light sensing device that can tell the microcontroller that the light intensity of your room is going low, so that you can turn on the lights. So for that, you will definitely have to connect a light detecting sensor, let's say an LDR, to your Arduino. So that's how Arduino will know that what's the situation in the outer world, and then it can pass on that information to your main microcontroller, that is the brain of your Arduino, and then it can decide whether to turn the lights on or whether to keep them off. Now, moving on, we talked about briefly about the Arduino boards. Now let's take a deep look into Arduino Uno, see its pin layout, and see what each of these chips right here mean, and how they work all together to bring life to your projects. The first up, we have this microcontroller right here. We already talked about that we have a microcontroller that does the decision making for you. And this is basically pretty much the can be thought of as the brain of your Arduino, and will be responsible for controlling all the flow of communication between rest of your Arduino. And then we have this USB interface chip right here. The function of this chip is basically to control the flow of information through this port. We can see this is a USB jack. So it is basically used to upload your code from your laptop or your computer to your Arduino. So for that, we will use this USB jack. It is also used to provide power to the Arduino, because we need power to turn on the electronics. So you can provide power through this port as well. Or alternatively, you can also use this power jack right here. So let's say if you do not want your Arduino to be connected to your laptop all the time, then you can disconnect this USB port once you have uploaded the code. Once you have uploaded the code, you can disconnect this USB jack and provide power through this power jack. So you can use any type of power that is between 5 to 9 volts. So let's say you can use AA batteries or a 9-volt battery supply. So next we have these 5-volt voltage regulator and these capacitors. These are basically responsible to ensure that any power that is provided to Arduino is within the safe range for this microcontroller. Because we know that microcontrollers can't sustain high voltages and can't really work on AC voltage as well. So basically we have these capacitors right here. They filter out the AC components and provide a smooth 5-volt DC supply for this microcontroller. Next, we have these ICSP headers. So let's say you have some certain type of a project that where you do not want to connect your Arduino with your laptop. Then you can use these ICSP headers to upload your code. There are some specialized machines that can upload your code to your Arduino instead of connecting your laptop to your Arduino. And then next we have this crystal clock. It basically performs all the timing functions for the Arduino. So let's say you were trying to make a blinking LED project, right? So you would want your LED to turn on for a certain time and then add a delay and then turn off for a certain time. So what this crystal clock does is basically controls the delay functionality, and the timing functionality for the Arduino. So next up, we have this reset button right at the top left corner. What it does is basically restarts the execution of the code. So what it will do is reset the execution of the code from the very first line, and you will be able to see the execution of your code in a better manner. And then we have this power indicator right here. It basically tells if your Arduino is turned on or off. Now, let's talk about these most important components of our Arduino. These are the digital input and output pins, and as the name suggests, these are basically responsible for connecting your input or output devices to your Arduino. Now, all of these are numbered, and as you can see, we have input/output. That means you can use either of these pins for digital read or digital write. You will obviously have to specify that which pin you have your device connected to and what is the number of that pin right here. We'll see the details about the syntax of how you can actually do that in the later section. But just now, to give you a brief idea, we can see that we have all of these pins numbered here. And then we have these analog input pins. These analog pins ensures that, let's say you have an application where you do not want your input sensor values to be just zeros or one. Then you can utilize these analog pins to connect your sensors. So let's say you were making the same light automation system for your home. So you will preferably use an LDR sensor, and LDR sensor, as we know, is a variable resistor, and variable resistors have a range of values, not just 0 or 1. So what you can do is connect your LDR sensor through these pins. Now we saw that we have digital input and output pins, and we have the analog input pins. Now, if you see right here, we see a PWM mark. These are basically a sort of analog output pins. They basically allows the Arduino to output analog values through these pins. They are marked with this tilde symbol. These pins, pin number 3, 5, 6, 9, 10, and 11. So let's say you are making a remote control car, and you wanted to add the functionality that you can accelerate your car or deaccelerate your car. So for that you would require a speed control mechanism. So what you can do is that you can connect your car connections through these PWM pins, so that you can output a range of values between 0 and 255, and depending on that value, if it's closer to 255, it will be speeding the car up, and similarly the vice versa as well. Now, moving on, we have these power connections right here. We have this V-in pin, as we already talked about. We have this USB jack, which can be used to supply power, and we have this power jack that we can use. It's mostly used. Let's say you are making a remote control car. So, as you know, cars are mobile. That means they're always moving. So you can't really keep them connected to your computer. So what you can do is supply power through either this power jack or through this V-in pin. This V-in pin does bypass this voltage regulator and the capacitor, so you'll have to make sure that you provide the right voltage for this microcontroller. And then we have this ground pin so that you can have the common ground for your whole Arduino circuit board. And then we have this voltage output pins. So what these two pins actually does is basically it can extend the power from this Arduino board to any other sensor. So let's say you were making some sort of a project where your sensor requires a breadboard. You're all, I'm sure, are already familiar with how breadboards work. So what you can do is you can extend a line from this 5-volt pin to that breadboard and provide power for your breadboard and your sensors. And then we have this 3.3 volt pin that works in a similar way to that 5 volt, except it's it's of lower voltage of 3.3 volt. And then we have this reset and one other pin. We will not really go into depth about these two because they're not really oftenly used, and Arduino take care of much of the complexity of all of that in itself. Now, we discussed in detail about how an Arduino board works, what each of these chips on the Arduino actually mean, and how you can actually use these pins on the Arduino to connect your input and output devices. Now we'll see how we can write code for your Arduino and upload that code and bring sort of a life to your project and make it really functional. So for that, I will hand over the control to Ms. Basalim. Thank you.
I am Ms. Basaleen, and with me you will be exploring some of the features of Arduino IDE that can be helpful to you for making your first Arduino project. And then we will be looking into some of the basics of the fundamentals of the Arduino programming. So this is the Arduino IDE. You can actually search in your search bar Arduino and open it. So this is the Arduino IDE, and there are very some of the features of Arduino IDE that you should know for firstly starting with it. So the Arduino IDE is basically a cross-platform which is written in Java. The Arduino programming is basic C and C++ with some of the built-in functions of Arduino. We write the code over here in white space. This is the journal template of Arduino programming. We can compile from here and upload from here. And after compiling, if any of the error occurs in your code, then it appears in the top, in the bottom. The Arduino IDE have a feature that it also tells you which line have the error and what type of error it is. So there are other some features of the Arduino IDE, just as in the tools drop down, we have some of the options for choosing the Arduino board and Arduino port. The Arduino board that we are using is Arduino Uno, so we've been selecting Arduino Uno. But there are other boards of Arduino that you just watched, that we have Arduino Nano, Arduino Mega, so you can select according to what you are using. You have other options in editing from where you can increase and decrease the font size and increase and decrease the indent of your code. In the file option, you have another feature of Arduino IDE that we have some of the built-in examples in Arduino that you can use while you are working with those objects. Like we have a basic and most popular example of the Blink board, which I will show you now. So this is the Blink board. So to understand the Blink board, I would first tell you some about some of the basics of the Arduino programming. So we'll shift towards it. Right. So just as you watched when I opened the Arduino IDE, the this template appeared over here. So this is basically the journal template of the Arduino IDE, in which void setup and void loop are already did. So you might ask, what is void setup and what is void, what is setup? So I will clear all these things step by step. The void here means the return type. Void is a return type, which means that we are not expecting anything to be returned as a result. Or means that we are not expecting any value to be returned, any string or anything. Setup here is the name of the function. Setup is the function which runs only once and it is on the top of the Arduino program. In the setup function, what we do is basically we initialize all the variables that we are using in our Arduino program and all the pin modes that we are going to use. By pin modes, I actually mean that just as you watched, we have different pins on Arduino. So we define pin modes in setup. We will explore more about pin mode later. And we use the libraries that we have just initialized before the setup function in our Arduino program. Next, as you watched, we have loop. As the name suggests, loop is actually the one function which runs again and again. In loop, we have the logic of our project, and in loop, we have the logic or some of the instructions that are according to project, and these instructions run again and again. The loop function comes after the setup function. The loop function is also a void function, which means that we are not expecting anything to be returned from it. So just as you watched, we learned about void loop and void setup. Next, we have pin mode. As I already told you, we use pin modes and define our pin modes in our setup function. You might ask, what is pin mode? So as I told you, just as you watched, we have some digital pins in our Arduino, and we have some analog pins in our Arduino. So to define the pin mode, that whether we are using the analog pin or the digital pin, or which pin we are using, and in what mode. By mode, I mean that whether we are using it as output pin or as input pin. Just as we discussed that all the pins can be either used as input or output. So to use a pin as input, we need to define in our code that we are using it as input or we are using it as output. So in pin mode function, we have two parameters. The syntax of it is very simple. We just mention the name of the pen we are using or the number of the pen you are using. In Arduino program, you can actually give a name to your pen. So instead of just stating right away the pin number just as A0, you can write the name of the pin too. And next, we define the mode. So as we have defined here, A0 input, it means that I will be using this A0 pin as in the input mode. I will be taking input from this pin. Right. So then we have digital read function. Digital read function is not a void function. It means that we are expecting this function to return something. So the digital read function basically, as the name suggests, it reads something. We are expecting something from it to read, and the digital means that it would read only one of the two values. Either it would be low or high, 0 or 5 volt, just as turn and off. So we have only two states over here, 0 or high, 0 or 1, high or low. So in the digital read function, the syntax is quite simple. We just mentioned the pin on which the device is connected, from which we are expecting a reading. Just as you might use IR sensor in your project. IR sensor is a digital sensor, so you will be using digital pins for it. So if let's say your IR sensor is connected on the digital pin 4 of Arduino, so you will write here the 4, and any reading that would be coming from the IR sensor, whether it is low signal or high signal, the digital read function will give you output of it. Next, we have analog read. Let's say if you have connected a device or that is reads value or gives you value that is not from one of the two values, that is not from 0 or 1. So you might so for that purpose we use analog read function, just as the LDR, which gives you reading in between of these two or greater than 2. So the syntax is quite similar to that of digital read function. We just need to mention the name of the pin we are using. Just as you know, we have analog pins from A0 to A5, so we will be using these pins for analog reading. Next, we have digital write function. The digital write function is basically a write function in which we ourselves define that what we want the pin mode to be. It means that whether, let's say you are using the pin number 4 of your Arduino program in your Arduino, and you want that pin number to be high. So you will define it yourself that whether you want it to be high or low. The digital write function is quite similar to that of the digital read and analog read function in its syntax. There is a bit difference of just writing value because we define ourselves that what we want it to be. This function is a void function. It means that we are not expecting it to read anything. Next, we have analog write function. The analog write function basically in this function we actually provide that what analog reading we want that pin to have. You might think that we will be using A0 to A5 pins for this, but it is not actually the fact. We actually use the PWM pins just as just as you watched that you have some tilde sign on some of the pins of the Arduino. Just as on pin number 11 and 10 and 9, you can see the sign. So we use these PWM pins for analog writing. Next, we have a delay function. The delay function is a time function and it is also a void function. So in delay function, what happens that we actually give an input of time and we define that in that time we actually define that for what interval of time the program should pause. So the input to the delay function is actually in milliseconds. Just as I have defined here the delay 1000, it means that we are having a delay of 1 second. Just as I told you, it takes the time in milliseconds. So 1000 is equals to 1000 milliseconds are equal to 1 second. So we will have a delay of 1 second if we write this instruction. So these were some of the basics of the Arduino programming that you must know for getting started with your first project. And here is the Blink code. So this is very popular and very simple code. As you can see in the complete code, we have some different lines, and there in the start we have some lines that are enclosed in some forward and backslash. These are actually called comments. The comments are ignored by compiler. They are not compiled. They are just for the user, that if you are coming after a long time and you are reading this program after a long time, that you might forget that what this program I wrote for. So the comments are actually for your own help. In comments, you actually define that what this program is for, what's the purpose of it. At times, we actually write in front of the instructions that what this instruction do, just as you can see here that in front of every instruction, we have some comments. So the comments are ignored by compiler. They are just for the viewer or for the user. So here is your blank code. The blank code actually have a void setup at first here. Just as I told you, we define the pin mode in void setup. And here we have defined the pin mode of LED built in as output. It means that we will be using it as output. Next, we have the loop. This body of the loop will be running again and again. In the body of the void loop, we have defined that the digital write function. And in digital write function, we have set the state of the LED built-in to high. Then we have defined the delay of 1 second. Again, we have defined its state to low now. And then we have a delay of 1 second. So as you can see that it will be high for a second. Then it would go to low state. Then it would remain in low for 1 second and it would go high again. So in this way, the LED will blink again and again, and you would have your LED blinking. So this is the blink code for Arduino. I hope that you were able to understand it. And so this was all about the fundamentals of Arduino programming and the features of Arduino IDE, the integrated development environment. We have actually different versions of Arduino IDE available. I would recommend all of you to use the latest version, and it is available for Windows, Mac OS X, and also for Linux. So we are done with our code part. Now we will shift towards project. So for this, we would be using a software, just as we told you, we will be using Tinkercad for it. So I will encourage everyone to shift to your browsers and follow us with the guide that we will be giving you. I will guide you how you can log into the classes that we have made for you to keep this workshop as most interactive as possible. So I will guide you on how you can join the classes that we made for you. If you have any query while I am making this, so you can mention that in chat. We will help you out. In your browser, you can search Tinkercad. Tinkercad is basically a software that we use for designing, and there is an option for circuit patching, so we will be availing that opportunity. So in that, you will click the option for join now, and students, as you all are, so you will join class. In the chat, we will be giving you a code. Also, you can follow me here. I have written the code. All of you can copy this code and join the class. Right, so you will join the class. Then you will have different options for accounts. You can choose according to your feasibility, and you can uh, join with the nickname if you have problem with if you are having any problem while opting these. So you can actually tell us in our in chat, and we can help you out with this. We will give you the nickname so you can join. So this is the dashboard of Tinkercad. I actually provided my credentials already, so I didn't provide it again. You will be asked for the credentials, so put in your credentials and you will get in here. This is the dashboard of Tinkercad. We have the option of circuits over here. We will go here because we are going to patch and simulate our circuit on Tinkercad. We have the option for create new circuit of this. Right. So this is the place where you will be actually patching and simulating your circuit. On the top left, you will be having a name over here. So I would actually request everyone to change this because we will be assisting you on your design of the circuit that you will patch over in here in this space. So I will request everyone to change your name so we can track you easily. You can change the name by double clicking on the name that is already written.
Mispa, we have some students asking for if you can show again the process for signing up for the class.
Yes, why not? So when you will write Tinkercad on your browser, you will get this. After that, you will choose the option of join now on the top right. Then you will click this option of students join a class. Then it will ask you for a code. This is the code that we will be using for our class. I hope you will be provided with the code in chat और आप यहाँ से भी copy कर सकते हैं. And after writing this code, you will select go to my class. Next, you will get the option for these accounts. You can either use either use these accounts or join with a nickname. You will be joining with a nickname. If you have any problem with these accounts, you will let us know in chat so we can help you out with that. Otherwise, we will be using any one of these accounts. So I will use my Google account. So this is the dashboard of Tinkercad. Since we will be designing circuits, so we'll choose the option of circuits over here. Then we will click the option for create new circuit. So this is the space where we will be patching and simulating our circuit. I will request everyone to please change their names over here. You can double click over the name that is written already and change it to yourself. All right. So once you have changed your name, now you can start patching and simulating your circuit over here. For the guide of simulation and patching, I will shift the control to Maria Manzoor. So over to Maria Manzoor.
Assalamu alaikum everyone. I hope my screen is visible and you guys can hear me.
Yes, we can.
Yeah. So coming towards the errors you are facing, first we will solve them and then we will move on. So first try logging in using Google, Facebook, or any other account that you have. And if you don't have it or you don't have access right now, just comment in the chat box and we'll reply with you with a nickname. So Ahmed or Misbah, can you please give the nickname in the chat box?
Sure.
So you'll be given nickname in the chat box, and after joining, you'll land over here. So we'll start in 5 minutes once all of you have made the account, and by a show of hands, you can confirm us if your account is made. So it's only 7 people right now. And anyone is facing any problem related, just type in the chat box and we'll help. So as you may see on my screen too, there are a number of nicknames. These are the nicknames. You can just pick one and log in using it. Just pick one of these. And if you are unable to log in using this one, then try another one. Maybe some other fellow of yours has taken this one. So first of all, try to log in using your Google account or Facebook account or something. But if that doesn't work, then use nickname. Okay, so I'll go through the whole steps again. You can just type tinkercad.com on your browser. And then click join now. So you have to type it in your browser and then click join now. In join now, you have to choose the option in green. Student join a class. And then join using the class code that you have been given. So it is 2T Using this board, you can join the class. Then you can join with any of these steps. So for example, I joined with Google. I can just choose my credentials. And you will land onto this page. From this page, you have to select the option of circuits on this left side. So you have to select this option right here. Click on it, and then click on create new circuit. So then we'll land on this page, and you can change this thing to your name by double clicking it. I hope this helps, and we will be making our project over here. So we'll be doing a hands-on session, and we'll be making our first Arduino project over here. So without wasting any further time, we'll just get started. And meanwhile, you have any queries, you can just type in chat and we will help you. So let's start with a recap. We have seen the commands in Arduino software and learned Arduino board. Now it's time that we implement the learning in a real world application. We will be making our first project on Tinkercad, just as you all have logged in and made your accounts. So this is Tinkercad environment, the place right here. It's the environment where we will patch our circuit and make connections of Arduino LEDs and stuff. The right side, the place over here, this is the place where you can search for components. For example, I can search for Arduino, and this will show me a variety of options for Arduino. So here you can search for multiple sensors and object programmers and output devices. So the code button right over here, you can click on it and it will show you a block where you can write your code. The start simulation button over here, it's to start your project demo so that you can visualize how your project is working. But before making a circuit over here, let's see that what project we will be making and how we can develop the concept. So for example, you have been very lucky and you have been employed in a company and your employer has asked you to make a system that controls the street light. So the employer wants you to design a system that turns the lights off when it's day and turns the light on when it's night. So there are two approaches to this solution. One that is being one manual and one automatic. So the manual approach is that you in turn hire a workforce, you hire a bunch of people and make them sit and turn the street light on and off. And it's not precise and it's time taking and it requires a lot of manpower. The second approach is that you can make a system, an automatic system using Arduino. So you can attach a few sensors to Arduino that can sense the light and turn the light, and then Arduino, as we know, it has the brain, the microcontroller. It can then make the decision to turn the lights on or off. So this is where Industry 4.0 comes. Industry 4.0 is that if we have two solutions or multiple solutions to a problem, we'll go for the solution that reduces human power in the scenarios where computers or microcontrollers can do a better job, precisely using less power and all resources. So now we have selected that we will be automating street lights using Arduino. Now how we will do it. So first of all, to automate or to make this project, first thing we need is something that can sense the environment, something that can read from the environment that is it dark or is it bright? Is it day outside or is it night? So first of all, we need something that can read from the environment, and then we need to link that thing to our Arduino so that thing which reads from the environment, we call that sensor. The sensor sends the information about the environment to Arduino, and Arduino in turn takes a decision to turn the light on or off depending on the logic. So first of all, we have to see what would be the right sensor. And the most commonly used sensor, which you all are familiar with, is light-dependent resistor or photoresistor. So light-dependent resistor is a component which has its resistance that varies with light intensity. So for example, if my light-dependent resistor is placed in high light intensity area, for example, directly under the sun, it will have low resistance. But if my LDR is placed in a low light intensity area, for example, I place it in a room and turn off all the lights, it will have higher resistance. So now we know that using LDR, it can sense the light intensity in the environment, and that changing light intensity can then be translated into changing resistance. Okay, so now we have seen in theory that the resistance of LDR changing with changing light intensity. But now let's actually check it out in Tinkercad. So I would request you all to open your Tinkercad in your browsers, as we'll check now. Do the LDR changes resistance with light intensity, and how much? So we'll shift to Tinkercad. Here we come in Tinkercad. I'll just close the code block. And from here, we will search about light-dependent resistor or photoresistor. So here you have to search for photoresistor. You won't find any option under the name of light-dependent resistor because it is present in this library as photoresistor. So just you have to click on photoresistor and drag it over here. Now the tool we use to measure resistance is called multimeter. So to measure the resistance, we'll find multimeter over here. Here it is. I click on it, drag and drop it in my workspace. To measure resistance of LDR using multimeter, I'll change its mode from voltage to resistance. For that, I'll click on it and change it to resistance. Now it has changed to resistance. I'll now connect my multimeter to LDR. Just like this, I have connected it to LDR. I would encourage you all to connect, and if someone can get a reading before me, that would be cool. So now I would start simulation. As you can see right now, the multimeter is showing a high resistance. And the light intensity, it's really dark. That means that this light dependent resistor on low light intensity is showing high resistance. And so you can just click on this LDR and access the slide bar, which shows if the LDR is in dark or is in dark brightness. So right now it's in dark, and we can see that the resistance is large and 180 kilo ohms. I can slide this bar to the right towards brightness, and as you can see, the resistance on multimeter decreases. And when it's near to full brightness, the resistance is 506 ohms. So now we see there's a great difference in bright areas resistance and in dim areas resistance. When the brightness is very much, we have a resistance of 506 ohms, which is very low compared to the brightness we have in dark areas, which is equal to 180 kilo ohms. So this resonates with the theory we already studied, that LDR in high light intensity has low resistance and in low light intensity has high resistance. So we'll wait for a couple of minutes until you all can measure the resistance of LDR using multimeter. You just have to drag and drop this on, drag and drop LDR and multimeter on your workspace, connect the terminals, start simulation, click on LDR and vary the brightness to see how much the resistance changes. You can zoom in if you want to see it in a zoomed in version. You can just zoom in using your mouse pad. So now we know that the resistance of LDR changes with light intensity. So we have found the ideal sensor to work with our project. Now let's come back to our problem statement. We have found the sensor, but now we need to establish its connection with Arduino. We need to send the sensor's value to Arduino in a way that Arduino's pin read. So Arduino's pin read a voltage value. And we have to send the resistance in such a way that it turns into voltage. And we will then print the value on serial monitor. We'll explore serial monitor now. So I'll shift back to Tinkercad, stop simulation, and I'll delete multimeter as I no longer need it. You can just simply click on it and select delete. Now to develop the logic and stuff, I will place all the components. First of all, search Arduino. Here you will find Arduino Uno R3. Click on it and drag it in your workspace. The next component you have to search is breadboard. Just click on it, drag and drop. The next component would be LDR photoresistor, which we have already placed in our working environment. And then we would need a resistor. Search it by name resistor, and you'll find one. So here we have our Arduino, and as we can see and as we have learned, we have a number of pins. These are the digital pins up here, right here, digital pins. And then we have the analog pins and the power pins. Here we have breadboard. So in breadboard, these two rows and these two rows, they are connected horizontally. So if I connect any single connection to this slot, it will automatically be connected to this whole row. Similarly, if I connect anything to this slot, it will be automatically connected to this whole row. On the other hand, if I connect it to any of these slots, it will connect vertically. This is my LDR. We already have discussed about it, and this is the resistor. So resistor can take multiple values, and we can just change the value of the resistance to what value we need by clicking on the resistor and then selecting the value. For example, in this case, I would want my resistor to be 10 kilo ohms because I don't want high current to be in my circuit or high voltage to be in my circuit. So because that can burn my LDR. So to avoid that, I will use a high resistance resistor. I'll just click on my LDR and drag and drop it on breadboard. I will click on my resistor, and you can change the orientation of your resistor or any other component using this tool of rotate. And I'll rotate it and drag and drop it to give it a series connection with LDR. So one of my terminal of resistor will be connected to the terminal, one of the terminal of LDR, so that both of these are connected in series, and the other two will be the freak terminals. Now, the first thing we need to do is in our connections, wiring connections, is to give power to Arduino, to the breadboard. For that, I'll just simply take a wire from 5-volt pin and give it to this row of breadboard. To start a wire, you just need to click on some place, some slot. So in order to start a wire, I'll click on 5-volt and extend the wire. Wherever I want to change the direction of wire, I can just click it. And here it goes. I've successfully connected a wire from 5-volt to the positive. You can change the color of your wire by clicking here. And for example, I can change it to red. The second connection I'll do to give power to my breadboard is connect from here. connect from the ground and connect it to the other row, the negative row. I'll change the color to black. This way I have given power to or from Arduino to my breadboard. Now I will connect the free terminal of my resistor to the ground of Arduino in this row and the free terminal of LDR to 5-volt VCC. I will change the color of my wire if I want. You can do so too, to red. By doing this, I'm actually providing a 5-volt voltage across two of my components. Then I take a wire from the common terminal and connect it to any analog pin. So I'm using A5. You can use any analog pin, just make sure that you remember it while coding. So you have to code according to the analog pin you choose. So what we have done right now, let's see what we have done. We have first of all given a 5-volt power across LDR and resistor, and then taken a wire from the common terminal of LDR and resistor and given it to analog A5 for input. We know that resistance of LDR changes with changing light intensity, but we also know that the input to any Arduino, so the input to any Arduino is basically in voltage. So the input of any analog pin, it should be between 0 to 5 volts. It is a range between 0 to 5 volts. And here we have developed a voltage divider circuit. So by developing a voltage divider circuit, we are actually taking out the voltage from this circuit, which actually depends on the resistance of LDR, and feeding it into the Arduino. So as the resistance of LDR will change, the voltage across my resistor will change also. As a result, the input voltage to my Arduino pin, that will change. So this is a way that we can convert the changing resistance due to changing light intensity in a useful way, which Arduino can read. Now this is the simulation part, and we'll now explore the coding part. For that, I'll click on code. On code section, click on block and select text. Continue. Over here, there is a code written already, but this is not the one we will use as it is not specific to our own project. So I'll just delete it. All right, so now we have to make a code specific to this project in which we read the value of sensor from LDR at pin number 85 and display it on serial monitor. So this block right here, you can click it to turn on the serial monitor. Now serial monitor, it's where you can display the values of variables or any message from your IDE. So right now we will input the value from LDR and display it on serial monitor. As we are taking input from LDR on pin number A5, so we will declare pin number A5 in analog in input mode. So for that, we will use pin mode followed by my pin number A5, comma, the mode in which I want to declare it. For example, in this case, it's input. Remember to end your line with semicolon, as this is the syntax of our Arduino IDE. I have declared my pin in input mode. Now, in order to use serial monitor, I also have to initialize my serial monitor over here. For that, I will use the function serial.begin followed by 9600 in the brackets and semicolon at the end. So serial.begin 9600, it actually initializes the serial monitor to display and tells it that throughout the code, we will display some values on the serial monitor. So there was a question earlier in the chat too that what is meant by 9600 baud rate. So it means that our Arduino and laptop, when we are transferring the data between it, it will be shared at a rate of 9600 bits per second. But you don't really need to know the meaning of it if you are quite beginner, and you just need to know that if you have to initialize a serial monitor to display values in it, you can just write this statement. Now we have done the initialization in void setup of our one-time declarations. Now in void loop, we will add statements which we want to repeat again and again. So for example, in this case, I want that the value of my LDR, it is taken by resistor. It is taken by the Arduino again and again. So I will read the value of LDR in this block in void loop, and then display it on serial monitor. So as this is connected to an analog pin and we have to read an analog value, so the function I will use is analog read. And I just write pin number in it, which is A5 in my case. So analog read function will read the value of voltage from 0 to 5 from the pin number A5, and it will convert into a number between 0 and 1023. So to store that number, we need a variable. I'll just declare that variable over here. For example, I can declare an integer variable. Int represents integer named LDR. And I can store the result over here. LDR equals analog read A5. So I have read the value from A5 and stored it in LDR. Now, in order to print on serial monitor, it will be a simple single statement. Serial dot print ln, and in it you will send the value of LDR. You will simply write the variable LDR. So this statement over here, this will print the value of LDR which we have read over here on our serial monitor. Now we can add a small delay. For example, I can add a delay of 100 milliseconds. So whatever value you pass in it, it's in milliseconds. So right now I'm writing 100. So that means it's 100 milliseconds. So as you can see right now, I have written the code and we can check now that if it simulates or not. So I'll just click on start simulate. And it has successfully simulated. So before going to results, just an overview, we have done the circuit patching with LDR and 10 kilo ohms resistor, and then written this code. Now the value serial monitor is showing us is 54. If I click on LDR and see what brightness the LDR is currently on, it's in dark brightness, which means it's in a dark room, very dark. So it means that when it's dark, the LDR shows values that are closer to 54 maybe, or LDR shows 54 value. If I increase the brightness by scrolling it, I can see that the value that is being displayed on my serial monitor, that is increasing. So it's going to near 900 and 1000. So now if my brightness is more, then the value I get is 9700, 970, 900, 1000. And if it's in a dark room, I get values closer to 54. So now we get an idea that in this configuration of circuit, if my LDR is placed in a dark room, I will get values closer to 54, which we can say that it's less than, for example, a mid value, which we can set as 400. So the value is less than 400, which is 54. And when the brightness increases, the value increases. The value that is being displayed by my serial monitor, which is actually the value being read by my analog pin, that increases. And in all the times, it's greater than 400, for example. So I can clearly evaluate that when my resistance, when my brightness it's less, my value is coming closer to 50 and less than 400. And when it's closer to brightness, it's coming greater than 400 and it's closer to like 900 and 1000. So I now want you guys to take a couple of minutes and complete the circuit patching and coding if you are doing it right now. And then if you have any queries, write in chat and then write down in the chat. Yes, we can attach load, and we will do in this in the next step. So we will add an LED in the next step. The maximum value of resistance of LDR that we just checked was 180 kilo ohms. and the minimum value of resistance was 506 ohms. So the value can, the input value can reach between 0 and 1023, depending on the light intensity you have. So right now in this configuration and the light intensity, we are getting a maximum value of 974 and a minimum value of 54. This resistor being used is 10 kilo ohms. So the value can be 1023 depending on the configuration of our circuit, what resistor am I using, what input voltage I am getting in this, and what brightness is this. So our circuits are not perfect to 100. And also in the real scenario, you'll see that it don't go to limits. So it won't go to 100% brightness, infinite brightness, or infinite darkness. So these are some things that make a difference. So it's always closer to the maximum value or closer to the minimum value. So we'll now move on to adding an LED in it. So first we'll move on to slides and discuss a bit. So we have established this communication. We have successfully read the value of LDR and displayed it on serial monitor. Now the task that is left is to use that LDR value. LDR stands for light dependent resistor or photoresistor. So use that and turn street light on or off. In this case, turn an LED on or off. So we have seen that when our LDR is in dark, it's getting a value closer to 54. And when it's in brightness, we are getting a value closer to 1000 and 900. So we can see that when it's in dark, we get values less than 400. And when it's in brightness, in daylight, we get a value closer to, we get a value that is greater than 400. So what our logic is that the value of LDR we receive, I'll just comment it. We can comment using 2 backslashes, 2 front slash. So we can comment and write our logic for understanding that if LDR value is less than 400, we want our LED to on. And if our LDR value is greater than 400, we want our LED to turn off. So we have to develop this logic. Now this logic and this stuff can be developed in 2 parts. The first part is to add the circuit components, the additional LED and resistor we need, and then add additional code for that. So first of all, we'll add the components. I'll just click here and search LED, drag and drop it. Then I'll search for a resistor, drag and drop it. So you can click on LED and change its color. For example, you can change it to orange or any color. So we'll keep it to red. I'll drag it and place it on my breadboard. You can click on the resistor to change its value. So it's always recommended to use a small value resistor with our LED, and don't turn on an LED without a resistor, because we want the current through LED and voltage across LED to be small, as small mini LEDs tend to burn out due to high voltage. So I can turn on, I can change the resistance to, for example, 200 ohms. I'll change the orientation and drag and drop it to connect it in series with my LED. So right now I have connected the resistor in series with my LED. I'll connect the negative terminal, which is the cathode of my LED, to ground, and the positive terminal, which is connected, positive terminal of LED through the resistor to any of the digital pin. For example, I select digital pin number 13. So now I have connected my LED to Arduino. My LED is connected to pin number 13, which means that pin number 13 A digital pin will control if my LED has to be turned on or off. So to turn on the LED, I have to send a signal of high to my digital pin number 13, and to turn it off, I have to send a signal of low to my digital pin number 13. So we can now code this in our coding environment. So first of all, as this is a digital pin and as this is an output pin, we have to declare it in pin mode. So I'll simply write pin mode, pin number, which is 13, comma, output, as it is in output mode, and with a semicolon. In void loop, we have to make the logic, which we already discussed over here. And to construct a logic and to make to construct a logic for two conditions, we use if-else statement. So the syntax of if-else statement is if followed by your condition in these brackets. Then you have braces within which we write our statements to be executed. And then we have the else block. So in this case, if my LDR has a value of less than 400, I want the LED to turn on. Else, which means if the LDR value is greater than or equal to 400, I want the LED to turn off. So to turn LED on, I'll simply use digital write function to write high on my LED. Digital write pin number, which is 13 in this case, comma, high, and end with a semicolon. And to turn an LED off, I simply write digital write LED number, comma, low. So I've written this. I have first of all declared the new LED in pin mode. So whenever you add, I would like you all to pay more attention to this part. Whenever you all declare, whenever you all add an LED to a digital pin using this configuration, first of all, we have to declare it in pin mode output using the pin name and output. Then in order to write it in a condition, in for example if statement, we have to do digital write pin number, comma, high if we have to turn it on, and digital write pin number, comma, low if we have to turn it off. So I'll simulate the code to see if the code is fine and it works. So it has successfully simulated. Now, right now, as I can see, the value on serial monitor are low. It's less than 400, closer to 50. My LED is also turned on. And as we can see, the LDR, the brightness is near to dark. So you can, I'm again reading, you can change the brightness on LDR by clicking on it. So right now it's dark, my LED is turned on, and the serial monitor shows less than 400. If I change it towards brightness, as you see, just as my value became greater than 400, my LDR value towards brightness, the LED turned off. So the LED is off, and right now the LED turned on. So we have successfully set up a system that depends on light intensity and that can turn the light intensity, that can turn an LED on when it's low light intensity and off when it's high light intensity. So we'll wait for a couple of minutes. You guys can complete this code and then we'll move on to next segment. And meanwhile, if you have any questions, you can type in the chat box. So the value of LDR that we get is when we actually connect it to our Arduino and read it on serial monitor, just like in the first step we did. We change the value and get how much value the LDR is giving us and define the logic of our code accordingly. This is a question asked in the chat. Similarly, when you will do this project in actual environment using hardware, You will connect your LDR onto Arduino and check it in different light intensities that are in your experiment, or for example, the place you will finally put your circuit in, and see on what light intensity you are getting which value. And according to that, you will develop a threshold mid value and then define the logic. Yes, so in the code, first of all, we have to declare pin mode of the new pin that we have connected to our LED. So for example, in this case, my LED is connected to pin number 13. So I have declared the pin mode 13, comma output. Now, as it is connected to a digital pin, I'll use digital write pin number. And if I want to keep it high or low, and in this case, when it's the LDR has a value of less than 400, I want to keep it as high. I want to turn on my LED. So I have given it a high signal. And if the value of LDR is greater than 400, I'll just give it a signal of low. I hope that helps. So the analog pins, as we can see by name, the question is why did we not use A13 or D13 as declaration parameter? So the pins that we declare are just like they are mentioned on our Arduino board. So as we can see over here, the digital pins, they don't have the letter D with them to represent digital. So we can just declare them right away. But the analog pins, they have the letter A with them. So when we have to declare an analog pin, we have to declare as it is written on board A0, A1, A2, A3. And when we are using digital pins, because D is not written with them, we cannot add D in them. We'll just simply write the number. So the tilde sign that you have said, that means PWM pins. So if you have to write output an analog value to a pin number, then we use PWM pins to output. For example, if you want to output 9 or 10 or 15 to a pin, then you use analog write, and that's for PWM pin. So I hope you all have bashed the circuit and coded, and you have got the successful results of brightness and darkness. We'll shift to slides. And now I would like, yes, we can use digital pins as analog pins, only the PWM pins, only to output analog values, not input. So we'll take rest of the questions, journal questions after the in the Q&A session. And for the last segment, I would like to hand over the control to Ahmed Raza.
Okay, so now we will proceed to the most awaited segment, the giveaway. Okay. So you will be instructed to perform a simple and fun assignment that you have already performed in the task that we have taught earlier in the previous two assignments of Tinkercad. So if you have followed the instructions so far, okay, we have a question. Can you paste final code in the chat? Mariam, can you paste the code?
Yes, sure, I'll paste it.
Okay. Okay, now you have the code for the latest project we have done. So let me tell you about the instructions by which you will be able to win 3 of these DeepLift t-shirts. So the requirement for winning these t-shirts is that you perform the task we are going to assign you in a while. The 3 people that will complete the task to the earliest will be awarded these 3 t-shirts. And the task is add a second LED to the last code we have shown you. All you have to do is add a second LED that will turn on when the brightness is greater than 400. So you simply need to use another digital pin from 0 to 12 anywhere you want and program it in such a way that it would be turned on when your brightness is greater than 400. LDR response is greater than 400. Are the instructions clear? Do we have any questions in the chat?
In this, you have to have 2 LEDs, one which we have already programmed, and the second one will be the LED you will add. So the LED you will add will work opposite. So it will turn on when your LDR resistance is greater than 400. And it will turn off when your LDR resistance is less than 400.
So your time has started. People who will complete to the earliest can mention in the chat. We also have access to your works. And please make sure that when you are done with your work, make sure that on the top right, you can see there is written all changes saved, so that your changes have been updated, and then you may leave this workspace so that your recent activity is the measure for us to know when you have completed the task. Don't stay in this workspace after you are done with the project.
Meantime, you guys can also ask any question or any query you have. We'll address them and simultaneously we'll be checking your codes. So the task is that in this circuit, you have to add another LED. You have to add another LED, connect it to any of these digital pins, and code it such that the second LED will turn on when the value of LDR is greater than 400. And it will turn off when the value of LDR is less than 400. So you have an LED which is currently working. It turns on when the value of LDR is less than 400. You just need to add another LED which turns on when the value of LDR is greater than 400. So once you are done and it's written all changes saved, then you can close the tab. Just make sure it's all changes saved, and so that your last visited time is saved.
Yeah, submission is automatic. You don't need to do anything else. Just after you are done, just leave the workspace or close the tab.
All those who have joined using their nicknames, please also mention their nickname in the chat. As you can see on top right of my screen, once I don't do any changes to my circuit, it automatically saves. So if you have joined the classroom and you are working there, you don't need to actually submit it. Your project will be automatically saved in our classroom.
Okay, I think we have got enough submissions. Mariam, I think we should explain the code now for that task and move to question and answer session.
Yes, so I'll explain the code and then we will move on to question and answer session. Meanwhile, the team looks at your circuits and we will then announce the winners at the end of the session. So here's the code. What we have to do is just add a LED. For example, here I have added a blue LED. I just changed the color by clicking on it and changed it to blue. Connected the anode, cathode, the negative terminal to ground, and positive terminal through a resistor to a digital pin. In my void setup, I just did an additional statement of pin mode 5, output, and in my void loop, when my LDR resistance is less than 400, my original LED is turning on, but my second LED is set to low. And in else, my original LED is turning low, but my second LED, which is supposed to turn on when the LDR resistance is greater than 400, it's turning high. So I'll just start simulation. As you can see right now, this LED is turning on. If I change the brightness, my second LED will turn on and back to first LED. So I hope that's clear. And now we want that you share all your questions that you have, any queries that you have, and we'll answer them related to anything related to Arduino and the stuff we have studied till now. Also, all those who have submitted using a nickname, they have logged in using a nickname, then please write your nickname in the chat section.
Okay,
Alright.
so we have a question in the chat. Uh, which Arduino board was used in the mini satellite I talked about in the introduction? Uh, they were combinations of Arduino nano circuit boards along with other sensors and modules.
So there's a question, what are some of the most advanced devices that in which Arduino is used? So in home automation systems, you can just add on a Wi-Fi chip to Arduino and use it. You can make controllers using Arduino, for example. You can do key mapping. You can make automated cars and some of the industry-based cars which follow a same track for courage, for luggage loading and deloading. These use Arduino. So Arduino, you can apply Arduino to any project. You can make a robot arm using Arduino. You can do anything, even CNC machines. You can make a CNC machine using Arduino. So you just need to add other sensors and make the Arduino work using some code. Yes, you can only use the microcontroller standalone, but it's kind of tough for beginners to just go onto the microcontroller and start coding. In that case, what happens is you need to make sure you get a 5-volt regulated power supply. You need to make sure that all you have a great understanding of embedded C assembly language, and you need to make sure that your memory in it is correct, your power supply is complete. You need to add the crystal clock to it then. So it's good to get started with a development board, and then move on to Arduino. So for the projects are So can you rephrase your question? Are there any special security features in Arduino? As in, we can add stuff, but what does this actually mean? What are some of the projects that you have personally worked on using Arduino? So you can actually go and visit our website, deeplift.tech, or you can go and visit our YouTube channel, DeepLift. And we have worked on ultrasonic sensor, IR sensor, LDR, and made cars using it and home automation using it. So these are some projects we have worked on. Serial monitor is a part of IDE. We can use LCD as an alternative if we want to connect to hardware. So remotely, there are two ways. Either you can use a Wi-Fi module. So ESP 8266 is a commonly used Wi-Fi module for remote controlling. But an easier one is to just buy a Bluetooth module if you don't have a range issue. So you have to control from close. So you can buy a Bluetooth module, and you can connect your device. You can connect it to Arduino and then control remotely from your mobile, or you can use a Wi-Fi module. ESP is one of the commonly used one. Node MCU. Can Tinkercad run heavy codes? So you can check the limits of Tinkercad, but the limitation also comes that for heavy codes you need to have like a very good. You also have like good hardware setup for that code. And Tinkercad that only provides you components, and there are multiple hardware things, for example, that you want to simulate, but they may not be available. But this is a pretty basic code, and you can write much bigger and complex code than this, and Tinkercad will work on it. We can program the microcontroller without Arduino board, but it becomes really complex, and you cannot no longer write in this simple code which we have just written. You have to like write a complex code in embedded C or assembly language. You can develop any system using Arduino. So you can use Raspberry Pi or ARM microcontrollers. You can use this stuff if you want to do hardware stuff, but you don't want to use Arduino. You can use Raspberry Pi, and there are ARM microcontrollers. You can use them. Well, for the security stuff, I apologize. I don't have much detail related to it, but we can. There would be many protocols related to it using Arduino, and you can surely drop us a text or email on our credentials, and we'll be happy to share the details after this session. LCD write in the difference is between the. I hope I am audible.
Yes, you are.
All right. So the difference maybe between the type of like we see that over here, um, analog read and write, the input type of data and the output type of data, that was different. So maybe for LCD write, it displays as an ASCII code, or maybe you forgot to just put double quotation around what you wanted to print. So if you want to print a text message, you have to write it in quotation start. So it would be like quotation mark start your message, for example, it's start quotation mark end, and then it should print correctly. But we can check this. Raspberry Pi is commonly used for if you want to do other than Arduino, or there are ARM-based microcontrollers, SMT. I would like to ask my team if the results are ready and have been shared.
Yeah, the winners have been finalized. We will be sharing them in a while.
All right. There are several microcontrollers and their development boards. 8051 is a microcontroller, ARM-based microcontroller. Then you have SMT, Raspberry Pi.
Assalamu alaikum everyone. The winners have been decided. The winners are Huzafa Irfan, Mohammad Safiullah, and Sohaib Ikram. Congratulations, guys. You'll be contacted shortly. You'll be asked to fill out a form and you will receive your t-shirt, inshallah. Thank you.
All right, so I think with this we'll conclude our workshop. Thank you so much for your active participation. We hope you had a good learning experience and gained a better insight into using Arduino. Do check out our YouTube channel and website. We have many more Arduino projects and tutorials there as well. And if you still have any queries, you can always reach us on our YouTube channel or our Facebook page. Our website is deeplift.tech, and we'll share the YouTube channel link in the chat below as well. We would also like to thank our organizers for giving us this opportunity, especially Cyber Security Club and IEEE. It was a great learning experience for us as well. So I guess that's all from our side, and everyone take care and stay safe, and Allah Hafiz.
Noman, have you shared the form with the winners? Like they can fill this out right now.
Yes, the form has been shared by Amna. It's in the chat.
Perfect. The form for the winners, that specifically,
Huh.
not the feedback.
Yes, the form for the winners has been shared in the
All
chat
right.
by Amna.
So all the winners can fill out this form, and it's mandatory to get the shirt to fill out this form.
Okay, so winners are requested to stay for a few minutes more. And thank you, Team DeepLift, for such an insightful session. And we hope to organize much more session on Arduino as well. And yeah, thank you, IEEE, for collaborating with us. And that's a wrap. Kindly fill the feedback form because certificates will be awarded to all those people who have filled the feedback form. And the winners, please kindly fill the winners form as well.
All right, Mariam and Ahmed, do share the DeepLift contacts in the chat below as well, so that they can contact if they have any queries.